what's up everybody? My name is Bruce. Today I'll be presenting an unboxing and build of the Voxelab Aquila X2. I have 8 years of experience in building and using 3D printers. The Aquila X2 is the newest model of FDM printer from Voxelab. Voxelab is a subsidiary of FlashForge. The list price on the Aquila X2 is $235. The Aquila X2 is an upgrade of the original Aquila. During the build process, I will offer special tips, some of which are not in the owner's manual. If you follow these tips, your printer will perform very well. So, let's get started with the unbox. Okay, the first thing I like to do is to ensure that we select the proper voltage. On the back of the chassis unit itself, there's a yellow sticker and a red switch. You can use a screwdriver to change the position of the switch to select a different voltage. My unit shipped with a default of 115 volts. Make sure you select the proper voltage for your country. And now this will be our first bonus building tip, number 1. Okay, bonus building tip number 1. This is easier to do before you assemble everything, which is why I chose to insert it here. You're looking at the X carriage here, and there are 3 wheels on the X carriage. One wheel has an eccentric nut on it. That's what my finger is pointing at. With this nut, you can adjust the tension of the wheels on the extrusion. Each one of the axes has one or more of these nuts. The X carriage has one eccentric nut. The Z carriages, we have 2 Z carriages, and each one of those has one eccentric nut. And the Y carriage has 2 eccentric nuts. So in total, you need to adjust 5 eccentric nuts. We are first going to adjust the X carriage eccentric nut. The idea is that you want to adjust the carriages so that there is no play, so that the carriage will not wiggle on the extrusion, yet the carriage will still move smoothly on the extrusion. You can do this by adjusting the eccentric nut to tighten or loosen the tension, and you should just barely be able to turn the carriage wheel while holding the carriage still so that there's just enough slip that you can turn the carriage wheel. You must adjust all axes carriage wheels. Failure to do this will result in a printer that is not very precise or may have other issues when printing objects. Here you can see the x-axis carriage and the x-axis extrusion. The wheels must ride on the extrusion, the channels that do not have holes. Select the two channels that don't have holes and insert those two channels so that the wheels ride in those grooves. When inserting the extrusion, be careful because the edge of the extrusion is very sharp and it can damage the pulley wheels. Again, what we're trying to accomplish here is to eliminate all play in the carriage, but yet have enough looseness that the wheels will roll smoothly in the channels on the extrusion. Use the provided wrench and turn the extrusion nut one way or another to loosen or tighten. Now we will adjust the Y. Grab the two opposite corners on the Y on the bed and try and rotate the bed. If it moves like it did for me in the video, you'll need to adjust the eccentric nuts on the Y carriage. On the left side of the bed, underneath the bed, there are two eccentric nuts. These are what will be adjusted in order to remove the play. Again, using the provided wrench, adjust the eccentric nuts to remove play, but do not make them so tight that the bed will not move smoothly. And now you can see the play has been eliminated from the bed. Now we are going to adjust the right side Z carriage. Again, when placing the carriage on the extrusion, be careful because the ends of the extrusion are very sharp. You don't want to damage the pulleys. Put the carriage on the extrusion. Use the eccentric nut to adjust the tension so that there is no play but yet still smooth movement on the extrusion. And now we will adjust the final eccentric nut on the left side Z carriage. The left side Z carriage is very heavy, so in this case I use the extrusion weight itself to ensure that there is smooth movement but yet no play. We will be starting with step number 1 from the instruction manual, which is to install the two Z Extrusions, one of which has a Z limit switch. We need 4 M5 by 45 screws, which can be found in bag number 6. We will install the Z extrusion with the limit switch first, which belongs on the left side of the base unit when looking at it from the front. Turn the base unit on its side, hold the extrusion with the Z limit switch above the holes, insert the screws from the bottom, and tighten them into the extrusion with the limit switch on the top. Do not fully tighten them at this point, as you will be adjusting it a bit later. Now that the left side's done, we'll repeat the same steps on the right side. Flip the chassis over to the other side, take the other piece of extrusion along with 2 additional screws and secure those to the base as well. Now we will proceed with step 2, installing the Z-axis motor and screw. We will need 2 M4 by 20 screws. Bonus building tip number 2. There should be a tiny air gap between the Z-rod and the motor shaft. So before you tighten the screw in the coupler, ensure that there is a small gap between the two. When installing the motor, do not fully tighten down these two screws. At this point, you want to ensure that the Z-rod is parallel to the extrusion, and then fully tighten the screws. And now step 3, install the X motor and the pneumatic joint on the extruder. For this step we need 2 M5 by 14 screws and 1 M6 pneumatic joint. We will also use the supplied open-end wrench to install the pneumatic joint. The pneumatic joint screws into the brass insert, first with your fingers and then use the open-end wrench to tighten. Just be careful not to over-tighten. To continue, now we will install the X and E motor on the X extrusion. It's best to put the screws in from the back side, the non-extrusion side, and they will line up and go in the holes in the extrusion. Note that on the extrusion there is a larger drilled out hole for the screw for the pulley wheel to fit into. And now for step 4, we will install the X belt, the extruder, and the right side Z carriage. To begin with, we need to place the extruder on the X-axis extrusion. Again, do this carefully so it doesn't damage the pulley wheels. Next, we will install the right side Z carriage on the Z-axis extrusion. Install the screw on the innermost hole first. We will only be installing one screw at this point. To continue, we will feed the belt underneath the pulley wheels to ride in the extrusion channel. Step 5 is to install the X-axis tensioner and the X-axis belt. We will need 2 M4 by 8s, 2 M5 by 14s, the X-axis limit switch, and the X-axis tensioner. We need to disassemble the X-axis tensioner by removing the nut. Now we need to slide the belt through the pulley for the X-axis tensioner. And now we need to reassemble the X-axis tensioner by sliding the pulley into the housing. Pay attention to the grooves and the ridges, and slide the pulley in the housing. Then take the adjusting wheel and turn it 1 or 2 turns on the screw, no more. Now fasten the tensioner housing with 2 M5 by 14s. One on the front side and one on the rear side. Now we need to complete the install of the belt. take the left side of the belt and slide the belt through the groove in the carriage on the extruder. Then on the right side belt, ensure the belt wraps around the pulley on the X motor, and then install the belt in the slot on the right side of the carriage. If you find that the belt will not reach the right slot, ensure that you can release as much tension as possible using the adjusting wheel. Now use the adjuster on the tensioner to increase tension on the belt, but do not over tension. Generally, when the end of the screw starts to become flush with the wheel, you are near the correct tension. Move the extruder back and forth to ensure that the belt does not slip. Our final task in step 5 is to install the X-axis limit switch using two M4 by 8 screws. To verify the assembly is correct, slide the extruder towards the limit switch very slowly, and when it reaches, you should hear it click. Step 6 is to install the X assembly on the base unit on the two upright Z extrusions. At this point, take the X extrusion and line it up with the Z extrusions, the two carriages. The one carriage with the motor also has a nut that the lead screw must go into. So once you reach the lead screw, slowly turn the lead screw to feed it into the nut and to move the carriage down on the Z extrusions. If the Z carriage falls under its own weight quickly, that means that you do not have the carriage wheels tight enough on the Z extrusions. Now it is time for final adjustments of the X and Y belts. For the X belt, adjust the X belt tighter or looser until you have smooth carriage movement of the extruder head and the belt does not skip. Less tension is better than too much. Just make sure that the belt does not skip. Adjust the bed, the Y-axis, in the same manner, adjusting the tension screw until you can move the bed with a minimum amount of force, but yet the belt does not skip. Step 7 is to install the gantry extrusion with the handle and the LCD screen. For the gantry with the handle, we will need 4 M5 by 25 screws. Place the gantry on top of the Z vertical extrusions, and 2 screws are used on each side of the gantry to secure the gantry to the Z vertical extrusions. You can fully tighten all 4 of these screws and then tip the machine to the left and the right and completely tighten the screws on the underside of the Z extrusion, which we did not fully tighten in the beginning of the assembly. Next, we install the LCD using the LCD bracket, and 2 self-tapping screws. Position the LCD bracket on the back of the LCD with the 2 holes and use the self-tapping screws to secure to the back of the LCD. Now it's time to attach the LCD to the base. We do this using 2 M5 by 8 screws, putting them through the lowest holes on the bracket and attaching to the front of the extrusion. Now we must plug the cable into the back of the LCD. The cable can only be plugged in one direction as it is a keyed connector. Step 8 is to install the spool holder and the extrusion end covers. For this step you will need the spool bracket, the spool pipe and nut, 2 M4 by 6 screws, 2 M4 T-nuts, and 2 plastic 2020 profile covers. We will install the profile covers first on the top gantry. Simply push them in the ends on each side. Be careful as the extrusion is very sharp. Now we assemble the spool holder to the spool bracket, put the nut inside the channel, and then slide the spool holder from the back side into the nut and simply twist the spool holder to tighten the nut and secure. Now we need to install the spool holder on the top of the gantry. We put the 2 screws in the holes on the spool bracket, and then we use the extrusion nuts on the bottom side of the screws. Only turn them on 1 to 2 turns. Once the nuts are started, then you will line up the nuts with the channel in the top of the extrusion, and you will use your Allen key to tighten up the screws, which will automatically self-tighten the nuts within the channel. Step 9 now is to hook up the wiring and the PTFE tubing for the hot end. The first wire we will hook up will be for the Z motor. There are 4 black wires. The connector can only go in one direction, and the Z motor sits on the bottom of the base unit. Firmly push the plug into the motor. The next wire we will hook up is 3 wires, and this is for the filament runout sensor. Mine was labeled silk. Again, it only goes in one direction, and firmly push the plug in. Now we will hook up the E stepper motor wire, 4 black wires. Plug only goes in one direction on the extruder stepper motor. Firmly seat the plug. Next is the X stepper motor wire, 4 black wires. Go in the bottom side of the X stepper motor. Again, firmly seat the plug. Now install the X end stop switch wires, labeled X, 2 wires, and again firmly seat the plug. And finally install the AC plug in the back of the base unit. Now that the wiring's done, we need to connect the PTFE tubing to the extruder. So the PTFE fitting, you push the PTFE tubing into the fitting as far as you can go. It'll go in about 10 millimeters or so, a little bit less than ½ an inch. But ensure you push it in as far as possible. Then once you've pushed it in, there's a ring. You need to pull that ring back out without pulling the PTFE tubing out. Just pull the ring back out. Bonus building tip number 3. This is a temporary solution, but it should get you by long enough to be able to print your own line claw. There's a special clip known as a line claw that previously was supplied by Voxelab in order to keep the PTFE ring out from the PTFE coupler. They no longer supply that with the Aquila or the Aquila X2. So find a small zip tie, secure the small zip tie around the ring in such a fashion that it will keep the ring pulled away from the coupler. This is what will prevent the PTFE tubing from popping out of the coupler. At this point, the assembly is now completed. There are still a few things to do before you can print with your Aquila, but I'm not going to cover those in this build video. The first item you need to do now is level your bed, and there are probably 100 or more videos on YouTube about leveling your bed. Once the bed is leveled, then you'll need to load filament. After you've loaded filament, then you can attempt to print one of the objects supplied on the SD card that comes with the Aquila. Good luck! The Aquila X2 comes with a 1-year warranty. The last page in the user manual explains how to contact customer support should you need any assistance with your printer or if there are any parts that need to be replaced. There is also a very good support group available on Reddit. It's an unofficial Voxelab Aquila support group where we support both the Aquila and the Aquila X2. We have over 2,000 members in the group today. The name of the subreddit is Voxelab Aquila. Google search will help you find us. I hope you have enjoyed this video, and I hope that it has helped you in building your Aquila X2 to the best of your abilities.